In this tutorial, I'm going to explain you the meaning of slope in linear regression. So this is a simple linear regression model statement. There's one y and one x. And the question we're going to ask is that, or I'm trying to answer is that, what does the slope mean? Namely the b1. As we know that in linear regression model, the y has to be numerical data. Sometimes it also has another name called continuous data. For x, it can be either numerical data or categorical data. So let's first look at the situation where x is numerical. So when x is numerical, so this is data example. As you can see that both x and y are numerical. And we can plot these 4 data points on an XY framework. So these are 4 data points. We can add the labels. And based on this data point, we can get the linear regression model. The intercept is 2 and the slope is 0.6. So what does the slope mean? So here we can remove the raw data point, and now we only focus on this straight line. So we can add 2 data points. So if x is 3, then y is 3.8 on this line. And if x is 4, then y is 4.4. So there are 2 data points on this straight line. And we can add another 2 lines and then correspond with on the x-axis. So the difference is 3 and 4. The difference is 1. And on the other hand, on the y-x-axis dimension, the difference is 0.6. So the x-axis 1 and the y on the y angle, the difference is 0.6. So as you can see that, this shows that the slope is the change of y when x change 1 unit. So that's the basic idea about the slope when the x is numerical data. Let's look at another situation where x is categorical. This is the data example. As you can see that both x, y are different from the previous data example. Again, we can plot these 4 data points on a XY framework. So notice that the x here is categorical, and we use dummy coding 0 and 1. So we can also plot these 4 data points and add a label there. And based on these 4 data points, we can get the linear model, which is y equal to the intercept is 2 and the slope again is 0.6. So we got the exactly same linear model with different data points. So since that we got exactly same linear model, we can see that the slope has exactly same meaning, namely the change of y when x change 1 unit. For the categorical data, the meaning of slope is the same actually. But there's another angle. If you look at the mean for the group that when x is 0, the mean is 2. So the 3 plus 1 divided by 2 is 2. And for another group, the mean is 2.6. So here you can see that the slope actually has another meaning, namely is the mean difference between these 2 groups. Yes, 2.6 and 2 difference is 0.6. And we can have another observation. We can say that, okay, this straight line also passed the point 0 and 2, and another point 1 and 2.6. So that's another observation we can have. So to summarize, when x is either numerical or categorical, this statement is always true. So the change of y is the slope is the change in y when x changes 1 unit. In addition, when x is categorical, there's another layer of meanings. So when x is dummy coded, namely 0 and 1, slope is the mean difference between these 2 groups or 2 labels within x. In the statement, I specifically say that it's for dummy coding. What about that is not dummy coding? Let's look at that again. So for instance, so instead of using 0 and 1, here we use 1 and 2. So it's not dummy coding. Let's just plot it again. So 1 and 2, yes. Here we can get this straight line again, a linear model. As you can see that compared to the previous one, the slope is the same, but the intercept different. So it was 2, now it is 1.4. So since that the slope is 0.6, so the meaning still is the same, yes, the change in y when x changes in 1 unit. If you calculate the mean, 2 and 2.6. So again, the second meaning is still true, is that the slope is the mean difference between these two groups. So even you change from dummy coding to this non-dummy coding, 1 and 2 coding, it's still the meaning. These two meanings can still carry on. Again, another observation is that it passed the line, the 2 points, 1, 2, and 2, 2.6. So that's first observation. Another observation is that you change the dummy coding to another coding, to this coding, it only changes the intercept, but not the slope. Okay, you might have a question that we use 1 and 2, and what about 1 and 3? So you can code it as 1 and 3, and let's see what happens. So you can plot it again, 1 and 3. You can get another linear model statement here. As you can see that this linear model statement is totally different from the previous one, in both the intercept and the slope. So the first meaning, following the logic we just had earlier, so basically slope is 0.3 is change of y when x change 1 unit. And if you calculate the mean, again, the mean is 2, yes, 2 and 2.6. So you can see that the meaning of slope, you can basically is 0.6 divided by 3 minus 1 is 2. So there's another layer of meaning, namely that the slope is the ratio of mean differences divided the differences between these two coding numbers. And again, that's one observation, is that it passed the 2 points, 1, 2, and 3, 2.6. And another observation is that it changed from dummy coding to 1 and 3. It changed both the intercept and the slope. So final summary, that when x is either categorical or numerical, that the statement, the meaning that slope is the change in y when x changes in 1 unit. So this statement is always true. But when x is categorical data, then the slope has another layer of meaning. It means that it's the ratio of mean differences between two groups and the differences between two coding numbers. Of course, for simplicity here, I'll only focus on we only have two groups. We know that in linear regression, the categorical variable can have like 3 labels. But then it leads to another problem, which that you need to have a 2 independent variable to deal with that it has 3 labels. But that's I will leave for another videos. So that's it for this tutorial. Thank you for watching. If you have any questions, feel free to comment down below, and I will do my best to answer the questions you might have. Thank you for watching.